Good morning, code milkers. Today we're going to look at the 30-day LeetCoding coding challenge again. Today we're on day 5. Let's see what we got today. Best time to buy and sell stock 2. I've actually done the first part of this question. I've done the first version of it, buy and sell stock 1. So hopefully that'll help with this one. Let's read this. Say you have an array for which the ith element is the price of a given stock on day I. Okay. Problem. I'm just going to say what our input is. Input is array. I'm going to guess they're integers because it's a price. We'll see if that assumption's held up. Design an algorithm to find the maximum profit. You may complete as many transactions as you like. Buy one and sell one share of the stock multiple times. You may not engage in multiple transactions at the same time. You must sell the stock before you buy again. Okay, so once we've bought one stock, we can't buy a different stock. We have to just sell that first one. Okay. So the problem is find the maximum profit in a list of stock prices on given days. Okay, so the element, the integer represents the stock price on that day. So each element is a different day in, let's say, a hypothetical week. Let's look at an example. We have 7, 1, 5, 3, 6, and 4. First impressions, I'm thinking this is a peak and valley problem where you're trying to find the lowest value and then you're trying to find the highest value after that. So it resembles like an actual valley to the peak of a mountain. You want to find the highest value before it decreases again, sell at that point, and then find the next valley, buy, and then peak, sell again. So you're just traversing valley to peak, valley to peak. That's my first impression. We'll see if it holds up. Okay, so this returns 7. Let's see how that is explained. Buy on the second day, so on 1. Buy on 1. Sell on 5. Profit 4. Buy on day 4, price 3. So let's index 3, we buy on 3, which is our next valley. If we think of 1 as a valley, 5 as a peak, 3 as a valley, and then the next peak would be 6. So 6 minus 3 is 3. 4 plus 3 is 7. And then the last value, 4, it's just, there's nothing after it, so it's not a peak or a valley, it's just part of a mountain. Okay, that example makes sense. Let's look at another one. 1, 2, 3, 4, 5. This is going to be 4 because 1 is the valley, 5 is the peak, 5 minus 1 equals 4. That one makes a lot of sense. And we've got 7, 6, 4, 3, 1. Net yields 0. Okay, and that's because decreasing order means there's no valley to peak. Because if we can imagine it's just going from the peak here, 7, down. If we want to buy low, sell high, we would have to buy high and sell low, which is the opposite of what we want to do here. We want to find the maximum profit. And if we bought at 7 and sold at any of the days, we'd actually be negative. We'd be less than 0, which is the lowest profit we want to make, which is nothing. We want to break even at the minimum. Okay, and I'm gonna include one more test case here because I'm noticing a pattern with at least this first one. The valley and peak happen to be directly next to each other, like 1 and 5 or 3 and 6. I know that's different for 1 to 5, but I want to include 7, 1, 5, 3, 5, 6, 4. And this would be, so we would sell on 5, which would give us profit of 4. Then we would buy on 3 and sell on 6, which would give us 7. So it's the same value because we are still doing 6 minus 3, which is 3 plus 4 is 7 of profit. So basically we have to find a way to compute, derive the valley and the peak. So valley, if we look at this last example I gave with the extra 5 in index 4, the first valley is the first element where the next element after it is greater than it. Okay, so if element is less than the next element, it is the current valley. The peak is if the element is greater than valley, of course, and greater than the next element's value. So an example of this would be 3, 5, 6. 3 is the valley because it's less than 5. 5 does not qualify since 5 is less than the next. 6 is the peak since 6 is greater than 4, next element. Okay. Oh, something else that might work. I just thought of this is if in the example, let's look at that 1, 2, 3, 4, 5. The value is obviously at 1, and we think of selling at 5, but we don't have to just sell at 5. We could sell at every day in between, and would we still get the same answer? Let's see. Okay, so hypothetical iterations of this loop. Let's go 1 and 2. We'll break it up into sections like this. Yeah, so we'll start at 1 and 2. The 1 is less than 2. So we could sell and still turn a profit in that 1 day window. So that would give us 1. In the 2 to 3 window, we could sell and get a profit of 1. Three to 4, it's the same deal. 3 is less than 4. by our logic, we can sell that day and still turn a profit. And then 4 to 5, 4 is less than 5, which yields 1. And then when you add all the profits together, we have 4, which is actually the correct answer. So it looks like we could treat this algorithm in two different ways. We can think of it as a stock trader who wants to hold onto the stocks until the hypothetical peak is reached without selling in between. So like an example that would be buying at 1 and then implementing our first algorithm where we wait until the current element is greater than the next one. So we wait for the highest peak to sell instead of thinking more like a short-term trader who is buying and selling on a daily basis, trying to turn just like incremental profits. And this is where we see this one, where so long as the right element, so like the next element is greater than the first one, we can subtract the 2, and that's we add that to the profit. So it looks like we can do this in 2 different ways. Data structure, we can just do this with a loop and a variable to store the profit integer. Our algorithm is declare sum, point at 0, and let's start our loop at, we can either start our loop at the first index, so 0, or we can start at the second index, 1. The benefit of starting it at 1 is that if the array's length is actually only 1, it will break preemptively and it will just return 0, which is the right answer in that case. Either way, it's good. I'm gonna start loop with counter starting at 1, and in there we'll do if nums I is greater than nums I minus 1, then we add to our profit, actually be our sum. Sum, we add the difference of nums I minus nums I minus 1. Then at the end of that, we just return our sum. I think that mimics what we were talking about here well. So 1 to 2, the current element 2 is greater than the previous element 1. So we add the difference between them, which is 1, to the sum. And we do that for each time. Let's try that out. Let profit equals 0, or let I equals 1, I is less than prices length I plus 1. Then we'll return profit. If prices I is greater than prices I minus 1, we're going to do profit plus their difference minus 1. Let's run the code. I hope that JSON parse error doesn't come up again. That was very strange. Okay, so that works. Let's try it with our custom test case, 5, 3, 5, 6, 4. And we'll try it with 1, 2, 3, 4, 5, and 7, 6, 4, 3, 1. Nice. Okay, and let's try it with an empty array and then an array of just one element. It should come back 0 and 0. Nice. Okay. Some questions about this. If I was doing this in an interview, I would ask if we're guaranteed that the array only has integers, because they don't explicitly say it in the details of the question. They might throw in floats, they might throw in strings or objects which contain the stock prices. You can't know without asking. It's a big assumption to assume the inputs will always be correct. So you should ask about that. Trying to think of any other edge cases that might get tripped if I submit this. I can't think of any others given the directions. Let's go ahead and run this, see what we get. Nice. Let's see how we did on the speed. This is a linear solution, so O of n. We go through the array once. 80% of JavaScript submissions are beat with this, pretty good. And how we do on memory. Doesn't really say. I don't know. Okay, well, there's a linear solution to best time to buy, sell. Well, no, best time to buy and sell stock 2. Hope you enjoyed. Have a great day.